All right, so welcome everyone to our Spring 2018 Computer Graphics class. And this is going to be section 1, I think. Yeah. So Monday, Wednesdays, 8:30, that's the section 1. And I got another section that's on Thursdays and Saturdays at 2:30. Both the sections, they have their corresponding labs. Yeah, that sucks. Right. So for both the sections, we got a corresponding lab class. What's going to happen today is I will talk about the course itself, how we are going to go through the lectures and what I expect of you. I'll also talk about the marks distribution. And since I got back-to-back classes today, and this is the first class, I'm not going to utilize both of them, but it's more like going to be um, one whole class followed by a little bit of the other one. So to start with, I'll talk about the course. This is going to be a problem. Right. We'll see what we can do about this. I'll talk about the course, and then I will introduce a tool that we're going to use quite a bit in this course, which is going to be Blender 3D. It's a 3D modeling tool. So I'll show you how you can use that, and I'm hoping that you guys will work along with me because it's much easier done that way rather than me doing all the work over here. But this is certainly not going to help. I just hope that this stabilizes in a bit. Alright, so I don't think it's really needed for me to introduce myself because I know most of you by face already. Um, for the record though, for all our communication about the class itself and sharing the resources, I'll be using a Google Classroom, and this is the link to that. I haven't uploaded any of the materials over here yet, but I'm going to do that real soon. Um, and talking about materials, what I'm going to do is I will post links to all the screencasts from previous semesters, the ones that I have got um, linked to, and also questions from previous semesters. I will give you to them. Uh, I'll, I'll give them to you rather. And what else? Everything that I'm talking about is getting recorded, and that's going to happen for the other classes as well. So you will have a link to those from this classroom as well. And if you're going to submit any assignment, there will be plenty of those. You will submit them through this classroom, not by email or any other means. And I can also share your grades with you through this as well. So this is going to be our primary mode of communication. And if you need me um, for anything else, like the easiest way I think to communicate with me is to send me an email. That's my name, no wonder with that. Just send me an email. And, I'll try to get back to you as soon as possible. And my office is in room number 1101. That's the 11th floor of this building. Okay. I'll have everything written in the course outline. The reason that I'm not giving you the course outline today is because I need to decide on a few things after talking to you. So there will be three parts to this course actually. I mean, three main focus points, right? We will be talking about the mathematical foundation of computer graphics. So there will be a fair bit of math involved. Okay, and that's sort of a prerequisite to this course. If you're weak in mathematics, you will find quite a few topics a bit difficult. So what I'm going to ask you, if you're weak in mathematics, first of all, spend some time going through the following materials. Vector, that's going to be really very important over here. 2D vectors, 3D vectors, like dot product, how to do dot products, how to do cross products, how to project a vector on another vector, so vector projection, stuff like that, vector addition. So it's not just about finding the formula for each of these operations or looking at the actual operation itself. What I want you to understand is what they really mean and how we came up with those things. Understanding that concept is going to be quite important. We have covered vector in quite a few courses. You definitely had covered them in your school level, I think, already. School level and also in college level. And then over here in your physics course, there should be a fair bit of vector in there. So you need to cover that. If you forgot most of the things, yes, please spend some time talking about learning vector again. Your intermediate level books would do, but if you still need some more books to follow and which are more aligned with computer graphics, I'm going to share this folder with you. This is my Google Drive where I put my computer graphics related books here. I'm going to post a link to our Google Classroom, so you can go here, and the books that I would like you to follow is Mathematics for 3D Game Programming or Mathematics for Computer Graphics. Both of them will be quite easy to follow and well, really helpful in covering these materials. So if you pick any of these books, they will have a nice little chapter on vectors. So I'll ask you to go through the entire thing. I don't want to download this right now, so that's beside the point. So yeah, I mean, this is what I'm talking about, that we will need a lot of math, and vector is right at the center of it. Okay. We also need concepts of trigonometry. All right, so the very basic things like what sine, cos, and tan, how you calculate them, and also the addition subtraction formula, primarily these things. For example, if I ask you to expand sine alpha plus beta, right? What's going to be the expansion of that? You should be able to write that formula because we are going to use that in some other mathematical model for something called shading. Okay, so we need to trigonometry, and we also need coordinate geometry. And again, these are basic stuff like how do you translate, how do you rotate, or how do you scale stuff, all right? Or maybe, oh, no, not really. It's going to be covered in other ways as well. So vectors, trigonometry, and coordinate geometry, these are the most important math concepts that I want you to learn. And we'd also be working with matrices. So how can you add, subtract, and most importantly, multiply to matrices? You need to know that as well. Okay. So these are stuff about the fundamental concepts of the course, and they're mostly math involved. Okay. So one part of the course will deal with those things, and then we will have another part where we are going to do the 3D modeling. I'd say this is the easy part, also the fun part, and also the most tedious part because it's going to take a lot of time. What we are going to do over here is we are going to create 3D models of different objects that we see around the world. And let me show you some samples if I can. If Ethernet helps over here. If you go to blendswap.com, and there are many other sites as well. Let me try logging into some of these. Alright, so what you see over here is actually a 3D model. We are seeing, looking at a 2D picture of it. I hate this thing. So, where's the car? So, we will learn how to create 3D models, and we will animate them using a tool called Blender, which I will show you today. The nice thing about 3D models is that you can actually have them in real life as well. I mean, these are primarily used for computer games, or you can also use them in animations, short animations. You can create characters, you can animate them, you can tell a story. But also, it's possible now to print them, to 3D print them, to put them up as a showpiece, or actually use them as a tool. And you can print different parts, you can join them together, and they can actually work. So we will learn how to create these objects, and this site, this Thingiverse from MakerBot, it allows you to upload your 3D models, and then someone can download them or order for 3D prints. They will physically print that thing and mail that to you. Okay. So we'll learn how to do that. That's going to be one part of the course, and we'll also learn how to do some visual effects as well. Like we see that a lot in our motion pictures, that there are a lot of edits, heavy edits done in post-production, and let me show you some of those things. And since these are going to be the fun parts, let's say if I look for Avengers VFX, visual effects breakdown, I think I searched for the same thing previously. Excuse me. Alright, this is super slow. Alright, so right here you can see that the scene has been heavily edited, right? From where the actual shot was to the final one. And these are all done in post-production. So we will learn how to do some of these things as well. That we will take in a footage and then we will edit that to sometimes insert new 3D objects in the scene that were not there before, and also in some ways to remove part of the scene. Like on the top right you see that there is a green screen behind Iron Man. We can remove those parts and introduce something new right there. Okay. So in previous semesters we have worked with some of those things. I mean, these are the fun parts with of computer graphics. We can use the Blender tool to do all of that, to achieve those effects. So that's going to be the other part, and the final part, and that's where I need some input from you. Is it's about programming. So we learn the math concepts and we will create some models, but what do we do with them, right? We need to be able to control them in some way, and through programming we'll see how we can write programs that allows us to manipulate those objects, right? And that we will do with a open source library called OpenGL, Open Computer Graphics Library. And there are many different languages that have binding for OpenGL. We have binding in C, we have binding in C++. Well, OpenGL was primarily meant for C initially, but then we have binding for all other languages as well. So C, C++, Python, Java, we got all these things. We can write programs in all these languages, and we have support for OpenGL in each and every one of those. Okay. So this is where I want you to decide which language you're going to go with. And what I'm going to do over here is I will post a poll, like I've done in other semesters as well. Is I will ask you whether you're going to choose, I'll give you two options, not all these options, because I primarily work with C++ and Java. So if you are going to pick any one of those, I can write all the codes in one language, not in both languages. I mean, the codes, they're going to be very similar, but then there is still some sort of difference. So I need to understand, I need to allocate all the resources in one direction, not in both directions. I can actually help you set up the environment in both these languages and show you how you're going to go about it. But yeah, I mean, we need to pick one, not two. So that's that. I mean, in previous semester, all these codes that we have done were in Java, but before that, I had a few semesters where I coded in C++ as well. Right? So I created some robot-like objects, and we controlled them. We moved them around the world, and we did something like collision detection. When the robot was walking, if it hits an object, we need to be able to detect that. So this goes into some sort of like 3D game development. If you learn these concepts here, you can develop a game by yourself. So if you're going to ask yourself like what you will be able to do once you're done with the course, there are a few things that I think can help you with. Like you can pick a career in game development as a programmer if you're going to write code. You can also, if you're not good in programming, you can also go into asset creation where you create the 3D models and someone takes those 3D models and does the other things. Or you can also join a advertisement firm where you're going to create advertisements or maybe even short animations or work in post-production. All right. So there are many different avenues open. Or also, if you're going to research about computer graphics, if you're more interested about the fundamentals concept about it, there's a lot to do in that avenue as well. But that really needs a good concept in mathematics or also understanding how these things work. Okay. So this course itself, this computer graphics and animation, it opens a door for many different things. It's just that it's going to be a very involving course because there are many different things to do. And also when we go into the 3D modeling and animation, each of those things, they take a lot of time. Creating one model will take you hours after hours, and you have to sit at the computer doing just one thing. And that can be a bit of a problem for people with short attention span or who don't have enough time. So if you are one of those, I would suggest that don't be in any of my sections because I will give you a lot of tasks, and by a lot I really mean a lot. So if you can commit to that, then this is not going to be a problem at all. But if you can't, then things are going to be difficult. All right, and there is also this part about programming, which we will also focus on. So if you're weak in programming, maybe, I mean, in those parts, you will find that things are not being really easy on you. Okay. So to summarize, like what I'm expecting that you will have covered all these math concepts first, and also brush up on your programming language deficiency if you have any. Okay, we'll do a fair bit of that. For the modeling part, I mean, since we haven't covered that in any other course before, it's not a big deal. I mean, we will learn as we go, but this really means that you will have to spend a lot of time. So just make sure that you have the time available to spend on this one course. All right, this is what I expect. Let me talk about the marks distribution a little bit. So we got the for the theory course, we got the midterm exam, and we got the final exam. And these are already decided, right? The attendance part, that's already decided. What we have here is the assessment part, where we can have quizzes or assignments or a project even. What I'd like to do is I will give you programming assignments here. And there will be 2 of those, right? And that's how much? That's 25 marks. Right, so we will have 2 programming assignments, and I'll give you a specific task and you'll have to implement that. For attendance, yes, I will take record of attendance regularly, and your marks will be based on exactly how many classes you attended. For the first class, I'm asking you to sign a blank sheet where you will write your name, ID, and sign over there. But from next class, I'll hopefully bring a sheet where you again have to sign, but your name will be printed. So that's that. The midterm exam and final exam, well, I will give you some questions from previous semesters, and also I'll give you a question format for the current semester. Like, what are the things that will be covered in there? Is this clear? Okay. So there's not much to choose from over here, and when we go to the lab course, we got 10 marks for attendance. We got a lab exam, and I think I'm going to make sure that we have a lab exam somewhere in the middle of the course, because if we don't do that, then in the final exam we got 40 marks there, we got a Viva, 20 marks there, and also this lab exam. So like 70 marks for the entire course goes on a single day, and that's not really a good thing. And the lab exam in the middle of the course will also help you prepare for the for what's coming up. So that's that. Yep. But let me tell you, this lab course will be primarily focusing Blender, but this doesn't really mean that we're going to talk about Blender only in the lab part. See, we got 3 classes each week for each of these sections, and I can't really label a class as a theory class or a lab class. I'm going to utilize all these classes for whatever we are talking about. Sometimes we'll be focusing on theory materials, and we may go into lab class talking about the theory material. Right? It may happen. Okay? If you're going to register for computer graphics, the theory course, I'll ask you to register for the lab course for the same teacher. If it's Siam Shajib's section, go to his theory and his lab. Don't mix and match, because we'll be following different style, and it's going to be difficult keeping track in that way. Okay. So if you're in my class, like sometimes I'll be utilizing the theory course for theory classes for lab material, and sometimes, well, theory stuff will go over into the lab part. so I can't really tell where what goes, but I will try to keep things separate as much as possible. Sometimes it will not be possible. Okay. For example, when we are building a car, it will really take a lot of time, and probably we'll have two classes back to back, just doing that one thing, right? Building parts of a car, a 3D car. All right, so over here, this is going to be primarily focusing Blender as far as the grading goes, but in terms of delivery, it may switch from time to time. For the assessment part, or actually this is called lab report or assignment. Okay, that's the official name. So what's going to happen over here is you will get bombarded with a lot of assignments. And I'm actually looking at 6 assignments. I'll see if I can push in that many. 6 Blender assignments where you'll be creating 3D models, or you'll be given some 3D model, you'd be asked to animate them, record a movie, stuff like that. These are fun stuff. It's just that they take a lot of time. Alright, so for each of these assignments, you'd be spending hours after hours working at home. And also, the way we have prepared this class schedule this time, since we got another lab, we have tried to keep SPL free as much as possible. So if you don't have a good computer at home, maybe you'll be able to work from here as well. And use these computers to get your assignments done, or practice a bit, stuff like that. Okay. One thing I'd like to mention over here, that these assignments, these are all individual assignments. Okay, you'd have to work alone on each of these things. And over here, I can be a little bit lenient. For the programming assignments, you can work in a group of 3 at most, not more than that. Okay. Any questions? None? Alright, so for textbook, I will primarily recommend 2 textbooks. One is about modeling, which we will. This is not really about Blender, but it's about modeling techniques in general. It's called Digital Modeling by Vaughn. I think the name is Michael Vaughn. Let me check. No, not Michael Vaughn. W. Vaughn. Yeah. Right. Okay. So I have the PDF for that, right? And also, it's going to be difficult to find these books in market. Most of these things, like this digital modeling, I'm really not sure whether you're going to find a copy in New Market or Nilkep. Okay, it's unlikely. You can use the PDF. We're also going to use this other book, Interactive Computer Graphics. We're going to use the 6th edition of this book, Top-Down Approach. Okay, and we will also use a little bit of real-time rendering. I think we're going to use the 3rd edition of the book. Real-time rendering, that's the book right there. And we got slow internet. Alright, yeah, we'll see the preview right here someday. Now, all these books we got PDF for, and I will share them with you today through our Google Classroom, right? Those of you who are coming in a little bit late, I've shared the Classroom link right there. I'm asking you to join. Right away you can use the web interface, or you can also install an Android app. Um, Maybe they have iOS as well. So yeah, whatever. Like just install that application, and if I post any notice, you'll get instant notification. So for some reason, if I need to cancel a class, or if we need to schedule a makeup class, we can get notified. Um, if your assignment is coming up, it will also notify you about that. Really helps, right? And like I said, we're going to submit all our assignments through this classroom only. So you really need to um, join the class, and you'll get access to all these resources. I will share all these links. Okay, so that's about the textbook. As for the tools, we're going to use Blender for modeling purposes. We will also use some programming language. It can be Java, it can be C++, and we're going to use one library called OpenGL. Okay. So that's that. I'm not writing the list of tools right now, because that's going to be partially depend on your choice. I'm going to give you two options, C++ or Java. Based on whatever you choose, we're going to put that up, and I will post the course outline, formally writing down everything, maybe by the next class. Our next class is on Monday. So by Monday, we will have everything sorted out. Any questions so far? I think. All right. So uh, this is what I wanted to talk about as far as the course goes. Now, since for most of you have seen you guys in other courses, some of you are new in my course. Let me just tell you right away that if you're going to come in late, or if you're going to go away from class, you don't even have to ask for permission from me. Just walk in whenever you need. Um, yes, as far as Southeast policy goes, the attending classes physically, it's mandatory. You have to come here and attend the classes, and I can't really change that rule. It is what it is. However, from my end, I'm going to record all these classes, and I will post them on YouTube, so you can watch stuff again at home or from lab, wherever it's needed. The other thing is that you know but already that all these classes are going to be conducted in English, so that may be a bit of a problem for some of you. So if we got video recording, maybe you can watch it again, and if you don't understand a part, well, you can replay that over and over again. This is not really what I'm asking you to do. If you got any question at any time, feel free to stop me, and we can go over that. Right? I don't really have any problem with you guys asking about something that you don't understand. Okay, so feel free to stop me if I'm going too fast. Stop me, or if you don't understand anything, yeah, stop me right away. Like, you don't have to wait till the end of the class. All right. So that's pretty much it. And with that, let us jump into something we'd be using quite a bit. That's our Blender tool. Okay. In all these systems that we got Blender installed. So you just type in Blender, and that tool. This is a free 3D modeling tool, and I would say it is at par with most of the stuff that you see in market and that are being used in studios. Like, we probably have heard about 3D Studio Max. We also have maybe heard about Autodesk Maya. There's also ZBrush. There are many other tools that let you create 3D models. Okay. And more are coming up. Like, there's a new one called Rhino. People are using that. So you can use all these things. It's just that none of these 3D modeling tools, they're free. They're quite expensive. right? So if you're working as a student, what you can do is you can apply for a student license, and that's free for a certain period, right? But when you go into industry, these things are not free anymore, and they really cost a lot. Like I think I checked for the prices for Maya. I think a single user license probably costed around $1,000. So it's really not something that you can afford right away, unless you got a lot of money to spare. Okay. Um, the minimum requirement for running Blender is not much. I mean, you can run it on virtually any PC. If you got a Core i3 or Core i5, you can run that. It's just that when you have prepared your model and you need to render that, you need to create a 2D picture, or you want to create an animation, that's when you need a good computer. Okay. Because it's going to take a lot of time rendering these things out. And there are two ways to go. Either you get a very good CPU with a lot of cores, but probably it's better to get a good graphics card with a good graphics processing unit. So something like NVIDIA GTX 1070, if you can afford that, so, or if you can go higher, 1080 maybe. But these cards are quite expensive, and along with that, you have to get a good motherboard. You have to get a good processor. Okay. That's why I'm saying, like, if you don't have a good computer at home, you can come and use these computers we got in our lab. We got 2 graphics cards per PC, and they can render quite fast. Okay. These computers are old, like at least 3 or 4 years old now. So we went with the best graphics card we had at that time, like not the best, but we went for 2 of them. We have GTX 960, 2 of those cards on each of these PC. We also have 8 cores on the processors for each of these. So yeah, things usually run quite fast if you're using these lab computers. So if you can spare time, and if you got the lab free, I'll ask you to work over here. And if you got money to spare at home, like yeah, feel free to build a new computer. Um, so that's that. So I was talking about this Blender tool. I mean, this is free, and independent developers, they're using this Blender tool because the other tools, they're quite expensive, right? And Blender itself, I mean, this is free and it comes with a lot of features. You have heard about Photoshop, right? Adobe has a nice product called Photoshop. That's not free. Right? Everything is free in Bangladesh, right? We can go to IDB and buy a CD, or you can just download it off the torrent. But these are pirated stuff. I mean, usually you have to pay money to get these softwares, and they cost a lot more than the hardware itself. Software is always more expensive. I was talking about Photoshop. So Photoshop is not free, but there is another tool called GIMP, which does a lot of stuff that Photoshop can do, and this is free, right? It's just that Photoshop comes with a lot of presets. Things are a lot easier done in Photoshop, not so much in GIMP. But if you need to use a free tool, this is a very good alternate. And that's something I'll say about Blender as well. Blender being free, it offers a lot. Okay. The reason we don't cover Autodesk Maya or 3D Studio Max is that these things are not free. So when you go out in the market, probably you won't be able to use them on your own unless you buy them or get a pirated copy, and we can't really promote that. Okay. Once you learn Blender, it's not going to be too difficult to switch to Autodesk Maya or switch to 3D Studio Max. The basic concepts are still the same. It's just that the shortcuts would be different, the workflow will be a little bit different. It's not really a big deal to switch from one tool to another. Okay, so how do you get Blender? You just head over to blender.org, and you can download a version for Windows, or you can download it for Linux. Okay. Last time I checked, the latest version for Blender was 2.79. although they are working on 2.8, and that's going to be a major revision. So whether you're going to use 2.78 or 2.79, there won't be much difference, but with 2.8 they're coming with some really cool features, like they will have a real-time render engine called Eve. But for now, let's just work with whatever we got. Do you guys have Blender running on your PC right now? Are we ready? Okay. All right. So in today's class, what I'm going to do is I will show you how you can work with Blender. Like we will navigate through the user interface first, and then we will do something that we see right over here. Yeah, we will build this desk. The desk that we are using, we will build this desk, a 3D model of it, and we can save the file. We can look at it from different angles. We can also create a still image of it. We can also animate that if needed. So when you start Blender, what you see right here is a 3D viewport. Okay. That's where you'd have three important things. First of all, what you see right here, right in the middle, that's the object itself. That's the 3D object sitting right there, and by default, Blender gives you a cube. Okay. You can start with the cube, you can modify that to be anything that you want. Like from a cube, we'll see how we can make a desk. It doesn't really look like a desk, but we will turn it into a desk. We have another thing, that's the camera. We are looking at the cube, and what we do with Blender is we're going to produce images. It can be still image or it can be animation. So if you go into the render option on the menu, you can click on render and then render image. That will give you a still image of what you see. And that's actually based on what the camera sees. So the camera is looking at this cube from a top left angle, and that's what you see in the actual render. Okay? And there is another thing up there, right over here. You can see that there is a circle and there is a black dot right in the middle of it. That's actually the lamp. That's the source of light. Okay? In real life, we need all these three things to see something, right? If you try to relate this to our real life, let's say I want to look at this wallet. First of all, the wallet has to be there. If it doesn't exist, I can't see this, right? Then of course, I need my eyes. Without my eyes, I can't see this. That's my camera. What else? If I'm in total darkness, I can't see this. I need some light. So the object itself, then the eye of the camera, and finally, the light source. We need all these three things in a scene for us to see something. So this whole thing that you see in the viewport, this is actually a scene. A scene is composed of a light source, a camera, and the object itself. Okay? Let me set up a few things so that you can see exactly what I'm doing. Okay, so when you're working with Blender, you'd have to know a lot of keystrokes and what you do with your mouse, otherwise it doesn't really make sense. And over time, I'm not asking you to memorize them right away, but over time you will learn what you have to press, what you have to do to get something done. In this course, whenever I'm working with Blender, I'll try to emit whatever I'm doing. Like you see, I'm pressing mouse wheel. I'm zooming in, right? So it says mouse wheel up. So that's the first thing I'm showing you. If you scroll your mouse, being in the viewport, if you scroll your mouse up and down, you can actually zoom in and zoom out. Okay? And that's getting recorded as well. I mean, you see what I'm doing. If I want to look at this object from different angles, what I'm going to do is I will hold down the middle mouse button. I'm holding it down and I'm moving from left to right. That allows me to look at the same object from different angles. Is this clear? So I can look at from the bottom, I can look from the top, I can look from the side, I can do all of that. Okay? If I want to move this object to one side, to the left or to the right or top, bottom, I can do that. But for that I have to hold down Shift and then hold down middle mouse button. Then I can move this object. Okay? So two things with the middle mouse button. If you hold it down on its own and move from left to right, you're just pivoting around it. If you're looking at it from different angles. If you want to move it to a side or move it on the top or the bottom, you have to hold down the Shift plus middle mouse button. That does something different. Is this thing clear? Okay. All right. The next most important thing, and you will be using this thing a lot, is to select something, right? Right now we have the cube selected. How do I know that this is selected? You can see that there is a orange border around it. So in Blender, every time you select something, you will have a orange border around it. Let's say I want to select this camera. All I have to do is I have to take the mouse cursor over there and hit the right mouse button. So right mouse button, it was printed right there. Right mouse button lets you select an object. Is this clear? I can select an object just by clicking on it with the right mouse button. Okay, the rightmost one. So with your right mouse button, you can select an object. And let me show you an effect of moving these things. So we know that we can go into render and render an image. We can see this view, right? Let us select this lamp over here. And if I bring it down, see these are these arrows. We have a blue arrow, we have a red arrow, and a green arrow. They let us move the object in different directions. So if I bring this down and render this again, we will have more light on the side compared to what we have on the surface, on the top surface. Whereas if I move it up and render it again, see, now we got more light over here. Do you see the difference? Okay. So it really makes a difference over here. And if I move it away over here, then I will have light from this side. Okay. And if I use this green one right over here, and if I bring it over here, see? Now, previously this part was in total darkness. Now it's not, because we have the light coming from this direction. Is this clear? So what are the things we did over here? We used right click to select an object, and then we dragged along the three different arrows to place the object in a proper position, right? As you'd notice that these three arrows, they have special purpose over here. And these are color coded. The red one, that's for the x-axis. The green one, that's for the y-axis. And the blue one, that's for the z-axis. Since we're working in 3D, we got three different axes, and that's how we're going to control them. Is this thing clear? Okay, so that goes for the camera as well. So every time we render this, we see the same thing, right? It's right at the same position. But if you want to move this camera away, if I want to move it up somewhat, see the object will go down, right? Because the camera has moved up. So we can control each and every one of these objects. We can also control the cube itself. If I move it away, well, yeah, it will move a little bit to the side. Okay. So these are the primary things about navigation, like how do you select an object, how you move an object, how you look at the object from different angles. We have looked at all these things. One really important thing when you're producing images from Blender is how you're going to know exactly what it looks like when the camera looks at it. And for that, we're going to use a shortcut that's going to be 0 on your number pad. Okay. We got 2 zeros on your on the keyboards, right? 1 0 is on the top row, and there's another 0 on the number pad. We're going to use the 0 on the number pad. That takes you to this view, so you know exactly how it's going to look like when the camera looks at it. And if you want to come out of this, you press 0 again, and that takes you to this view. Okay. So I'm not going to show you a lot of shortcuts. There's a whole lot about all these things, but you will get to know about these things as we go along in the course. But for today, just with the very basics, we'll see if we can create a disk like this. Okay. So we got a cube to work with, and this doesn't really look like a disk. So the first thing I want to do is I want to make the top surface of this disk, which is quite thin. It's not like a cube, right? Squeezed down. So how can we make something like that? There are many ways to do the same thing. I'm going to show you one way of doing it, but this is not the only way. So when you have this thing selected, you can actually manipulate the dimensions. You can move this thing around, right? We have already seen that. But you can also scale it. Scaling means you can make this object bigger or you can make this object smaller. The shortcut for scaling in Blender is S. S for scaling. So by pressing S, let me show you over here. If I press S and if I drag this mouse, this is going to get bigger, and if I send the mouse inwards, then the object is going to get smaller. Is this thing clear? If I hit escape, it comes out of it. It doesn't save anything. So S for scaling, you go out, the object becomes bigger. You go in, the object becomes smaller. So that's that. Okay. But the problem right now is that it's making the whole thing bigger or smaller. Okay. I want to squeeze it down in one particular axis. What axis is that? We got a cube. Let me draw it over here. See, what we have right now is a cube like this, right? But what I want is not that. I want a top, something like this. This is what I want. So in order to do that, what I want to really do is I want to squeeze this down in this direction. I want to make it smaller. Okay. So what I'm asking you is which direction should I go to squeeze it down, whether it's going to be the x-axis, the y-axis, or the z-axis. The z-axis, because that's the blue one. Is this clear? So if you understand that part, the task is not really that difficult. See? S for scaling, and then you press Z on your keyboard, and then you go in. SZ is for scaling in Z-axis. If you, let me just show you the other options. SX makes it bigger or smaller in the x-axis. Similarly, SY makes it bigger or smaller in the y-axis. And SZ makes it bigger or smaller like that. Okay? Did we manage to make a top like this? Let me know. I mean, if you have any problem, let me know right away, and then we can move on to the next thing. S and then Z. And then you move your mouse to go inward or outward. One thing you need to notice is that Blender switches based on the context. We got our mouse pointer inside this 3D view, right? And then when we press SZ, this means something. If you take your mouse and put it over here or over there, it will change the meaning. So your mouse cursor has to be within a certain range for this to work. And everything that we're doing today is going to be based on the 3D view, the viewport itself. So yeah, all our commands are executed here. But as we move on to advanced stuff, sometimes we'll work over here and we'll press something else, and you'll know that when the time comes. All right, so to make a desk like this, what are the other things we need? We got the top, right? We got this part. We need two side panels that are going to be placed vertically. How are we going to get that? So this is really easy. When you go into Blender, and there is this, these are the many different tabs you have. If you go to the Create tab, there is an option to get a cube. So I pressed on cube, I got a new cube, right? And if I want to make a side panel out of it, again, I have to squeeze it down, but this time around, I'm going to maybe squeeze in this direction, which means that I'm going to squeeze in the x-axis, right? So S, X, and then make it smaller, like so. Is that clear? And when we do that, you see that this is not at the right place. Can we place them in a proper position? This side panel. We have learned how to do that. This thing is already selected, right? If I take this arrow pointer and move it down, and take this red arrow and then move this sideways, see, this is probably right at the perfect position. Okay. There are a few things that have gone wrong, like if you look at the desk that you're using right now, these things are not lined up. It has to go inward a little bit. This thing has to go inward, and if you look at the back side, there's also a little bit of gap over here. So from both these sides, we need to squeeze it inwards a little bit, which is again not really difficult because we can use S and Y and then make it a little bit smaller. So now we have a gap right from the edge. Is this thing clear? Okay. So that gives us one side panel, but we don't have the other side panel, right? We don't have this one. So we can get another cube. We can squeeze it and we can place it properly. No problem with that. But since we have already made this one side panel and that the other one is going to be exactly the same, why not duplicate this? Okay. How do you duplicate in Blender? You just press Shift D Shift D, that duplicates, and when I press enter, that duplicated copy will be placed right over there on top of this, and now it's a simple task of moving it away to something like this, right? So our disk is coming up. We got the basic shape ready. I think we need a we need a bottom part, and then we also need a placeholder for the case itself, right? So we're going to build that. And let me come with a cube again. Right, we got this cube. So first of all, we need to make it smaller. But it's not going to be as small as the top itself. It's going to be a little bit thicker. And then we need to move it down somewhere over here. The bottom part is actually aligned with the side panel, so we need to make it smaller. SX. Okay. I'm pretty much eyeballing things, so these are not going to be perfect at this point. But we can always make them perfect. It's not really a big deal. SY. Okay. Yeah, I think that would do for now. Okay. What else? We need something like this, but over here. So there are two ways to go about it. You can start from a cube again, or you can duplicate this. Let me just duplicate this for now. Once we duplicate this, we can move it to the side, just so. But we need to make it smaller in terms of height, because it doesn't go that all the way. So what should I do? SZ, make it smaller, and it goes up. Then move it down, like so. And we need another part to close the lid over here. And for that, we can actually copy this, or come with a new cube itself. I mean, this part is a little bit thicker. We'll need to make it a little bit thin. Doesn't really matter. I mean, let us just bring it down for now, and then we can make it a little bit thinner like this with SZ. And then we need to make it smaller by squeezing it in the x-axis. It's not in the right place, no problem. Slide it over. Make some adjustments, and we are pretty much ready. There are a few issues, right? For example, this thing is sticking out. So I need to move it inwards till it lines up properly. And these things, like I said before, right in the beginning of the class, that these things will take a lot of time, because you'd be making small adjustments to make things perfect. There are shortcuts to use numeric values to make sure that they are right of the same measurements, but I'm not going to introduce them today. It's just that getting the idea of creating an object like this, I mean, whether you understand this, whether you can create a 3D object, that's the most important part. Can we build something like this then? Okay. Do you have any problem in any part? Which one? How do you delete a cube? All right. So if you insert any object, whether it's a cube or a ball or whatever, when it's inside, you have to have it selected and then hit delete. There is a delete key on your keyboard. Just hit delete and then confirm that. Okay, so let me show you. If I want to delete this part, I have to select this and hit delete, and then it's gone. If I made a mistake, I can undo that, Control Z, like any other application. Yep. Hold down your middle mouse button. Oh, you have this thing selected. Hold down middle mouse button and then move from side to side. If you have shift selected, then it will move the whole thing. Alright, so that's that. If you want to build a back panel like this, well, it's the same thing, right? I don't have to show that. So what I'm going to ask you is that when you go back home, or if you're working here today, pick any real life object, right? See what you see in real life, and pick something that's simple, right? Like a desk. Don't pick anything that's carved, because I haven't covered those things yet. We can certainly make carved objects, no problem at all. You can easily do that in Blender, but to keep it simple, uh, pick something with sharp edges and try to build that by yourself. What sort of finishing? Oh, press escape. Escape. You'd have to select this part that's sticking out, the bottom part. Right click, and then you have to move it inward. So take not that, well, the red one, the red arrow. Yeah, and then push it inward. Okay, and it will probably help if you zoom up. These are all micromanagements, and yeah. Just press 0 and see where it's placed. Or what do you mean by the default view? Oh, you can zoom out. You can zoom out to see all these things. Use the mouse scroller. Zoom out some more. Yeah, that's the camera. That's the lamp. R for rotate. Okay, and yeah, it's a freeform rotate, but usually we don't do that. Just hit escape. Okay, if you want to rotate in a particular axis, you write that down. So RZ will rotate on Z axis. All right, so these are basic stuff. Whenever we work with any application and we're working on something, we need to save that thing, right? Because the next time when you come to work with the same object, you need to get this ready. So this is really easy to do in Blender. You just go File and hit Save. It gives you the location where you want to save this thing. Let's say I want to save it on my desktop, and you have to write a name. Every Blender file that you save will get the .blend blend extension. So this is our desk, right? So we can write des.blend and we can save that file. Let me close Blender. Next time when I open Blender, I can go to the file menu, go open, and open the des.blend. Is this thing clear? Okay, let us try to see how it looks like. If you look at the camera, I mean, this is the view that I get. But maybe I don't really like this view. I can right click on the camera view itself, and here is an option. If you press N on your keyboard, that brings out these properties, N, and over here, somewhere down here, there is this option that says lock camera to view. Let me zoom it over here. Where's my zoom? So we got this option, lock camera to view. We need to check that. Okay, when you have lock camera to view, we can actually move the camera by pressing G for grab, and now you can place it like that. You can hold down your middle mouse button, you can zoom up, or press G for grab. We have everything set, and now we can go into render image. So this is what I see. Okay, and all these things, these are shadows, right? So the problem is we have only one light source, and that's right here. It's giving us light from one location. If you have multiple lights, then maybe you'd have a better representation of that. We can duplicate this light and place it somewhere else. G for grab, and I'm going to place this here, and let me render this again. See, this looks a little bit different. Let me put the light down at this level so that we can have some light inside this object again. All right, so with multiple lights you can create different sort of effects, and that's what we will see. These are very sharp edges, and it also shows you that I made a mistake right here, that this panel is pushed a little bit inwards. I need to bring it out a little bit. We can do all of that. Just a bit. Okay, sorry about that interruption. So yeah, this is not perfect, and it's not going to be like we have to spend a lot of time to make sure that all the measurements are right, and there are better ways to do this. I just wanted you to see the very basic things, like if you bring in cubes, multiple cubes, you can actually make an object. Okay, so if you have the desk ready, maybe try to make a chair, right? Something like this. Okay. I'm going to introduce all these things in class, right? But I'm going to go a little bit slow. For those of you who got some extra time at home, what I'm going to suggest is go to YouTube and search for Born CG. Okay. If you go to his channel, Born CG channel, there is a playlist. It says Blender 2.7 tutorial series. I'd say cover the first 10 tutorials from that tutorial series. It covers the very basic stuff. I will also have them covered throughout the course, but I mean, if you have some time, this is really a good start. Okay. And when I say watch these videos, I don't really mean just watch them. You have to try them as along with watching them. Like, I mean, it doesn't really work otherwise. You have to practice everything that you see in the videos. Goes the same way for my classes. If I introduce something over here in class, you must try them by yourself at home, because things are going to be very difficult otherwise. Okay. Well, I thought I'd need a bit more time today. That's why I said that I will spend the entire class for the theory class and then a bit of the lab class, but it doesn't look like that. I'm pretty much done with whatever I wanted to show in this first class. So I'm not going to go over in the lab class today, okay? But from next week, we won't be missing any classes. We'll be utilizing all of them. Uh, we got the lab free, so if you guys want to practice, feel free to do that. Any question about everything that I talked about today? Nothing? All right, so I'll give you the course outline in the next class, and for now, this is where I stop. I will also post the video that about the entire class, whatever is recorded, and these things will be available right over here. So all the videos, they will go into a playlist. It's not going to be a public playlist, but if you have access to this classroom, you'll also have access to this playlist, and you can watch the videos. You'll get access to the videos from previous semesters, the questions from previous semesters, and all these things. Okay? All right then. That's where we stop. Thank you guys.